Welcome to the project demonstration of hybrid optoelectric sensor for current, voltage and temperature monitoring and controlling in overload transmission lines. So here we are going to monitor the transmission line. This is the transmission line, and in this we are going to measuring the voltage from this potential transformer and current from this current transformer CT and temperature from this LM35. And next we are going to changing the voltage with the help of this potential meter, and also we are making use of an optoelectric sensor, that is a LDR. So whenever the short circuit happened, then the LDR sensor will inform to the system like heavy lightning was happened from this transformer and transmission lines, and that will be identified by our light dependent resistor. So based on these sensors input to our PIC 16F877A, we are continuously monitoring these parameters and displaying the voltage and temperature continuously on the LCD. And also whenever the abnormal conditions occur, then the system will isolate the power supply to the loads by using this electromagnetic relay. And also we are going to send the message alerts to the predefined phone number with the help of this GSM modem. So here the abnormal conditions are high voltage, low voltage, and high current, high temperature, and also the lightning from this optoelectric sensor, electronic sensor. So the voltage sensors, voltage limitations are 210 below is low voltage and 245 above is high voltage. And current also we set for the limit of 60 watts. This is going to be the real time measuring of current and real time controlling based on the CT inputs. So whenever we set the limit, we have set the limit for 60 watts. Whenever we add the extra load above the 60 watts or above the 80 watts maximum, then the system will isolate the power supply and it will indicate it as high current. So let us see the flow. So we are going to provide the 230 volts input here, and this is parallelly to the load and to the transformer, this potential transformer. So the output of the potential transformer is 12 volts AC, as it's a step down transformer, and it will given as input to this regulated power supply board. So this particular regulated power supply board will regulate the voltage from 12 volts AC to 5 volts constant DC by using this bridge rectifier. So it will convert AC to DC, and after filter we will get pure DC, and after this 7805 regulator we will get constant 5 volt regulated power supply. Once we provided that to the PIC 16F877A microcontroller motherboard, it start reading input from the voltage sensor. So from here we are going to provide the voltage variable resistance, is a potentiometer, to A0 pin, and a temperature at A1 pin, and next current sensor, the CT, is to the A2 pin, and optoelectronic sensor at E3 pin, and B2 to B7 LCD, B0 B1 for GSM modem, and D7 is for the relay, and D2 is going to be the LED indication. And coming to this motherboard, so there is a reset switch first of all, so it will play a major role in our project. So this is the restart switch, right? This one is, and next this is a crystal oscillator, so which will provide the 20 megahertz of clock frequency to our microcontroller. The purpose of the crystal oscillator is it will start reading, it will provide the 20 mega pulses per second, and the microcontroller need clock pulses to execute the instructions. So what are the instructions? Reading sensors data and controlling that through relay and sending SMS, displaying LCD. So these are the number of instructions. So controller need one pulse for one instruction. Like that we are providing 20 mega pulses, so the microcontroller can execute 20 mega instructions in 1 second. So that is the speed of our microcontroller, and with the help of these 5 pins we are going to load the X code into our PIC microcontroller. So let us see the demonstration. Before switching on this kit, we need to insert a SIM card which should have the main balance or message balance, and better to use Airtel or VI. And also I forgot to explain this. So this is the potential divider circuit. So as we are using CT, as we know the CT is a step up transformer, so it will step up the voltage, and that's why we are going to converting by using the resistors. We are step downing that, and after the rectification and filtration we will get DC voltage. That's a variable DC voltage. Whenever the load is increasing, the voltage will be increased. So right, and after switching on the power supply, hold the switch. So why? Because we need to wait till the GSM modem get the signal. There is a light is blinking very fast. So right, now it is slow down. After this blinking light slows down, then only we need to allow the microcontroller to communicate with the GSM modem. So that's why we need to release the switch. Till that, when you switch on the power supply, we should hold the switch, and after getting the signal to the GSM modem, then release the switch. And we can see a welcome message on the LCD screen. So to this number we are going to receive the messages. Right, so now the voltage is 233, we set from that one, and temperature is 22 degrees. And now just I want to decrease the, so let us connect a load. Right, so now I am decreasing the voltage whenever it is below 210 volts. Right, now it is low voltage, the load will be isolated, and also will get the message alert. Right, so we got the message of low voltage, circuit got isolated. So after rectification, the person who is there at this section, he will check that and correct that, and again we need to reset the switch, then only the power supply will be reinitiated to the load. Alright, okay, and next coming to the high temperature. Okay, before high temperature, let us see flashlight. So if is any sparks is detected, so that highlighting will be detected in the LDR. And right, so now again it is indicated as short circuit. Again the system will send the message. Right, we got the message of short circuit, and same circuit got isolated. And next, overload indication now. So when we add this extra bulb, whether it is a 60 watts or 100 watts, then the load increased, and the system will check that with the help of this CT and this potential divider circuit. It will isolate the power supply to the load. Right. Right. So the same message on the displaying a LCD also, and we'll get the message alert of, right, we got a high current and circuit got isolated. And now let us see the demonstration for a temperature sensor. Now I am increasing with the soldering iron, but in real time it may be increased due to the heavy load or any short circuits. Right. High temperature on the LCD screen, as well as we will get the high temperature message alert. And the finally same in the manner of high voltage also. Every time the circuit isolated, then we need to reset the switch. So that's indicating the person who is going to reset that, he will know the parameters by seeing on the LCD, and whenever it is normal, then only he can reset that. Again we got the high voltage circuit isolated. These are the alerting messages for abnormal conditions.